All right, what we're going to look at is a justification sheet for things that we are going to want to say and the calculus justification that can accompany that. You see that your sheet has two columns for the justification and the alternate justification. Typically, you'll use the one in the first column that is the ideal justification. However, sometimes it's not an option. We don't know that information. And so then we would look at the alternate justification. Do we know something about a different function that can still tell us that same thing? So as we look at this first one, it says f has a maximum. Your ideal justification for that would be run through your first derivative. And so that would be saying that your first derivative, f prime of x, switches signs. And if it's going to be a maximum, it would switch signs from positive to negative, and you can abbreviate it that way. An alternate justification, we could run this through our initial function of f, and that would be that f switches from increasing to decreasing. Similarly, to say that we have a minimum, we would say that our first derivative switches from this time negative to positive to say that it's a minimum. And your alternate justification, if we didn't know the first derivative and we only knew the function itself, we could say that our function switches from decreasing to increasing. All right, next one, we want to say that we have that our function is increasing. And so on this, if our function is increasing, we would say that our first derivative is positive. Now, I do want to point out that if we were wanting to say f is increasing, we'll notice we use the derivative of that. Let's pretend we wanted to say that our derivative was increasing, then this would be our second derivative would justify that. It's the derivative of the function you're trying to prove is increasing. There's not really a good alternate justification for that, is that we would always use our first derivative for that test. So I'm not going to fill anything in that alternate justification column. Similarly, to say that our function is decreasing, we would use our first derivative, and our function is going to be decreasing when our first derivative is negative. All right, so our next one, when our particle is moving right and forward, similar to when our function is increasing, we would say that our first derivative to move our function right or forward is positive. There is kind of an alternate justification you could look for on this one, and that would be that your function itself is increasing. For our particle to move left or backwards, our first derivative would be negative, or our function would be decreasing. And for our particle to stand still, our function or our derivative is going to equal 0. And then again, not really increasing or decreasing, as our function is a horizontal line, is what you would look for in a graph to see that it is standing still. All right, our point of inflection. Now we move to our ideal justification being through our second derivative. So your point of inflection is going to run through your second derivative. And so we would want to say that our second derivative switches signs. Now notice I didn't say which direction because it doesn't matter. On this last page right here, I did very much say that it's going to switch from positive to negative to make it a maximum. When we're talking about a point of inflection, it doesn't matter which direction you're switching as long as it switches signs. There is an alternate justification. If we did not know our second derivative, to switch signs, your first derivative would need to switch from increasing to decreasing, or vice versa, or decreasing to increasing. That would make your second derivative switch signs. As we're writing these things, I do want to point out that increasing and decreasing are not the same thing as positive and negative, and we'll address that again here at the end, but make sure that you're not confusing the two or interchanging the two. If I say increasing, you can't put plus. Plus means positive values. All right, for it to be concave up, we would use again our second derivative. And for it to be concave up, your second derivative is going to be positive. Your alternate justification, if your derivative is not an option, all you have is your first derivative. In order for your second derivative to be positive, your first derivative would have to be increasing. Again, your ideal justification for concave down would be that your second derivative is negative. If all we have to work with is our first derivative, we could say that it is decreasing, would also justify concave down. All right, and then for our particle to speed up and slow down, it is a combination. You must have both your first derivative and your second derivative. And they have to be the same sign, either both greater than 0 or both less than 0. And then for particles slowing down, is that your first and second derivative have opposite signs. And again, we can show this like via calculus. So example on that is like f prime of x is greater than 0 when f double prime of x is less than 0. That would be showing opposite signs. For your alternate justification, you could say something like f prime of x is greater than 0 and f prime of x is increasing, because that is the same thing as saying your second derivative is also positive. So there are some alternatives to this in order for them to show that they have the same sign. And this would be a combination example where you would use the first derivative to say both. Where instead of saying f double prime is also positive, you instead say f prime is increasing. All right. So the warm-up actually is going to lead you into your worksheet today. But before we jump into that, I want to go back and address something that I just said on the last page, is that positive values, and again, this kind of will help you with what we're going to look at here. Positive values and increasing do not mean the same thing. I can have a piece of graph that say is here, and that piece of graph is positive values, which we would indicate as a plus sign, but it is decreasing because it is headed down as you move from left to right. Similarly, I could have a piece of graph that is below my x-axis. Below my x-axis means negative values. But that piece of graph, as we move from left to right, is increasing. So just keep in mind that positive and negative values does not mean the same thing as increasing and decreasing. So on that note, going to our warm-up here, it says we are going to sketch a graph that satisfies the given information. And what we're going to do is I'm going to kind of guide you to how you're going to do this on your assignment today, since I'm not there to help you. And you're going to sketch this graph that basically goes from -1 to 1, and it's going to satisfy each of the given pieces of information. So given a piece of information that f of x is greater than 0, that means, and we are drawing f of x, if it's greater than 0, that means the entire function needs to be above the x-axis because it is all positive values. If the first derivative is negative, that means that from -1 to 1, our function is decreasing. And if our second derivative is negative, that means that it is concave down. So we put all of those three things together, is that I'm going to draw a piece of graph that goes from -1 to 1, that is completely drawn above my x-axis, and that is decreasing the whole time, concave down. So an example of something that could look like that would be starting here, moving downward, all above my x-axis, and concave down. So let's do another example of something like that. If we were to have something, some slightly different information here. Okay, so f is increasing, they can tell us that, and that would be similar to f prime of x greater than 0, right? Increasing. that it is less than 0. So if our function is less than 0, that means it'll all be drawn below the x-axis. And that our second derivative is positive, and that means concave up. So my entire graph is going to happen below my x-axis. It's going to be increasing the whole way from left to right and concave up. So I'm going to start down here. I'm going to end up here, stay below my x-axis the whole time, and connect those dots with a concave up curve. Okay, so what you're going to see on one side of your worksheet is problems that look just like this, just continuing to piece together those 3 pieces of information. And what I want you to do is kind of answer those 3 questions. Question 1, is it above or below the x-axis? Question 2, is it increasing or decreasing? And question 3, is it concave up or concave down? And so then you'll create a graph from that. Now these 3 things again can come from different ways, like the increasing part, look, we had increasing, decreasing given to us from our first derivative, or directly from words. We had that it was, well, we could have concave up from the fact that it says f double prime is positive, or you could have concave up, concave up. Another way we can say that would be like f prime of x is increasing. So lots of different ways that they can give you the same piece of information, but it's these 3 pieces of information that you need to then address and draw yourself a picture of that. Your assignment then is the work